Hello everyone, welcome to Indian School of Physics. Guys, this is Nitin here, and today we are here with the Center of Mass and Momentum Conservation JEE mains booklet, and like similar to what we did with the work power energy, we are going to do here also. We will be revising this topic quickly, and at the same time, I'll request you to take the screenshot of this for your reading purpose, for reference purpose. In this booklet also I have included all important problems from this topic which will help you in scoring perfect 100 out of 100 in JEE mains. Again, this booklet is mains specific, JEE mains specific. So let's start this topic here very quickly. I'll be briefing this. In the meantime, you can just take a screenshot and follow how I'm going to take you in this topic. So center of mass definition wise, I think almost all of us should be aware of that. We are, especially in translational motion, we are replacing the entire body to a specific point which we are calling as center of mass, and we can assume that its entire mass is placed at one point, and this will help you in calculating translational kinetic energy as well as linear momentum of the system. So you can see here the center of mass is unique point where the weighted relative position of distributed mass sums to be zero. Mass moment definition, basically you can say sigma m1 r1 vector, m2 r2, m3 r3, like this we can add, and with respect to cm that product will be always zero. So in short, you can treat center of mass as one single point where in translation we can replace the entire body with a single point. And this is the famous formula for center of mass, RCM. For discrete masses, we can use sigma mi ri vector divided by total mass sigma mi ri, sigma mi. Okay? Total mass of the system we have to write in denominator. Now we can write, since r vector we can write as xi plus yj plus zk. So it's a x, y, z components of center of mass. By using the same definition, we can use sigma mi xi by sigma mi. Similarly, sigma mi yi divided by sigma m. So we can write for the x, y, z all three. You can, if you want, you can take the screenshot of this. Now this is a very handy formula and will be used in multiple places directly. For 2 point masses or two systems, we can replace with the system 1 as its own center of mass, and system 2 as its own center of mass, and then again we can treat that entire complex system as a two particle system. So this is very handy, and in multiple places we are going to use this. All right, so you can see in case of two bodies, the ratio of so I'll just brief you. You can do the reading, take the screenshot of this. So mass m1 is there and m2 is there. Total distance between them is given. So if this distance is d1 and d2, so we can write here, if I take origin at center of mass, I can write m1 into minus d1, m2 into d2 divided by m1 plus m2, and that is equal to 0. So we are going to get from there m1 r1 or m1 d1 is equal to m2 d2, and second will be d1 plus d2 is equal to capital D. On solving this, d1 and d2 will be known to you. So I'll request you to remember these results, and directly you can write, otherwise you can derive it also. CM will be closer to the heavier body. All right. Next. This is a JEE mains problem. So on a triangle, there are three masses given, and they are asking the location of center of mass with respect to 1 kg. So what we are going to do is we'll take origin here itself, and let's apply sigma mi ri vector divided by sigma mi, and that's how we can calculate location of xcm ycm. So calculation, I'm not explaining it to you, and I think you can do that. You can check the calculations also. If we move to the next problem here, consider a system of two particles with m1 and m2. First particle is pushed towards the center of mass through a distance d. Then by what distance the second particle should move? So location of center of mass is not changing. For individual it is changing. So definitely we can write a sigma m into delta ri of the, and that should be 0 because center of mass is not shifting. All right, so same definition you can apply here, and you will get how much distance you should move to the second body. All right, and yeah, one we are bringing closer, then another one also will be coming closer to the center of mass. Then this problem, the center of mass of the body lies always at geometrical center, lies always inside the body, always outside the body, lies within or outside the body. So now this is a good question, and people make mistake. So correct answer is it can be within the body or outside the body, but the concept here is whatever will be the external boundary of all the masses, it has to be within this. Now if I take a plate, so it is lying on the body. If I take any 3D object, then also it is inside the body. But if I take a ring like this, so you can see if we take the extreme of all the masses, it should be somewhere in between. So it comes here to r by pi distance for a uniform ring, but it is not lying on the ring. It is not present on the body. So just be clear with this, that center of mass will be present if we join the all external boundaries of masses. It will be somewhere within that. It may or may not be the part of body. So correct answer should be D. Then JEE Mains 2022, very simple problem. Body of mass m1 is given, m2 is given, position vectors are given, and the magnitude of position vector of center of mass of this system will be similar to the magnitude of vector. So just apply that formula and get this magnitude and check which one will have the same magnitude. All right. You can take a screenshot if you want for this part. All right. For this also you can take a screenshot. 3 blocks ABC are arranged as shown. If A is displaced towards B by 1 meter and C is displaced by B by 3 meter, at what value of B must be displaced so that COM of arrangement does not move? Just now we have done that sigma m delta r equal to 0 we can do, because center of mass is not shifting. So if when you'll apply, you'll get that answer. I'm not going to solve it. These are like very basic level problems, should be done by everyone. And if you're making mistake in such type of questions, then it's very difficult to recover in the exam. It will badly affect you. So just ensure that such mistakes will not happen from your side in such type of questions. Continuous mass system, so it is the extension. Basically sigma is replaced by integral for continuous mass systems, so no need to explain. I think all of you would have done in your classes when we derive these these formulas. Now non-uniform body, you can see linear mass density is given, which is a plus some function of x basically is given. Like this many questions I have done in regular class, and for all these functions I have told some kind of secret also, like the trick how to write answers directly without solving for these problems. So just those who are part of the courses can look for those tricks. In the regular course you will find them. So we are going to take a small mass. We'll write integral x dm and we'll calculate integral dm, take the ratio, we'll get the answer. So if you want, you can take the screenshot for this part also. See? Similarly, you can take the screenshot of this part. It is based on the previous problem, and it's old JEE Mains problem, and the exam name was IIEEE. A thin rod of length L is lying along the x-axis and its end at x equal to 0 and x equal to L. Linear mass density is given kx to the power n, where n can be 0 or any positive number. If the position of center of mass of the rod is plotted against n, then which of the following graph is best approximates the distance of xcm? So similar to the previous problem, it's much easier than that. What you will do is just plot the graph by using xcm is equal to integral x dm by integral dm. Okay. The next part is shape of these bodies. So I think everyone should know circular ring, geometrical center. If they are uniform, circular disc, same center, thin uniform rod, it is the midpoint of the rod. Triangular plate at the centroid. Square, it is the center of the square, basically the intersection point of the two diagonals. Rectangular plate, again intersection point of two diagonal. Solid sphere, geometrical center. Hollow cone, if it is hollow, it is h by 3. Solid, it is h by 4 from the base. Solid hollow cylinder, symmetrically you can say for the uniform body we are writing, so it is at the midpoint. And similarly here, if it is arc, so we can use that arc result, which is r times sine theta by 2 divided by theta by 2, or 2r by theta into sine theta by 2. Whichever way it is easier for you to use, you can use that part. Next, semicircle of radius r 2r by pi. It should be pi, by the way. Quadrant of circle of radius r. So previous result we can use 2r by theta. Theta is pi by 4 into sine pi by 8 will come. Sine pi by 4 will come. So 4r by pi root 2 will be the distance. Similarly, semicircular disc, it will be 4r by 3 pi. I think some font has changed. So p is basically pi here. So take a note of this. 2r by pi, 4r by pi root 2, 4r by 3 pi. Solid hemisphere, from the base it is 3r by 8. Hollow sphere, it is r by 2 distance from the base. Horseshoe magnet, basically. Now it is like a rod. For rod we know it is the at midpoint, and then if it is also like a straight line, then we can calculate. If it is a part of the circle, then also we can calculate. But wherever it will be lying within this boundary. Semicircular annular disc, when radius is r1 and r2, you can derive the result, or you can use this result directly. 4r by 3 pi, r1 square plus r2 square, r1 r2 divided by r1 plus r2. So you can use this result, can be very handy if you can remember this. Otherwise you should know how to derive it. So these are the other applications of basically sigma mi ri formula. ठीक है ना? So composite body, or you can say this body can be taken as one vertical rod and one horizontal rod. So vertical rod, it is here, horizontal rod, it is here. If mass is same, it will be the line joining of these two, midpoint somewhere. Now this part we can write as one vertical rod and 3 horizontal, and individually we can treat them. Now this I have explained just now. For a lamina with uniform negligible thickness, the formula of finding position of center of mass, basically mass will be sigma into area. So everything can be converted into area if it is uniform. So that is what I have written here. A1 r1 sigma ai ri by sigma ai. When a proportion is removed, so similar to the previous part, whether mass we are adding or removing, we are going to treat this as a single particle system. m1 r1 equal to m2 r2, and m1 r1 plus r2 equal to r. That formula we are going to use. All right. Now how center of mass will be shifting in different cases, whether you add some material or you remove some material. If you change the shape of this, maybe a rod is there and you convert this into a semicircular ring, or suppose uniform rod is there and then you are making it a baseball bat, then also center of mass will change. So either shape change or the mass density if you are changing. So addition of mass also you can follow the same m1 r1 equal to m2 r2, and r1 plus r2 equal to r. That logic you can follow. If you want, take the screenshot of this. I'll try to provide these books for download purpose. If you know, some good number of likes will come on the videos, so that I'll get motivated enough to make more such booklets. And you know, anyways, we can see here removal of masses. So from a disk, one part of the disk we are removing it. I'm not explaining this, but you can say this is the complete body, and then its center of mass is here. Now one part has been removed, so for the remaining it will be somewhere here. Now for the remaining, and this m1 r1 equal to m2 r2 can be applied for these two, and from there we can find this shift also. This is the shift, call this as x, and you can find same thing we can do for solid sphere, but just ensure that you are deriving these results and verifying. These are small questions. It will give you good practice, and chances will be that you will not make any mistake. And if some of these results you can remember, it will be well and good. Otherwise you should at least know how to solve these type of problems. Similarly, for if we are adding the two disks, then change in shift in the center of mass. Same, all these questions are based on same approach. For two spheres, we can say two spheres of same material, radii r1, r2 are in contact. The distance of center of mass from the center of first sphere is given. Similarly, the distance of center of mass from the second centroid of the second sphere. So these are the distances. Everything is based on m1 r1 equal to m2 r2, and r is equal to r1 plus r2. All right. After this, the position of center of mass is determined by the distribution of mass within the system. Consequently, the center of mass changes as the shape of the system, and relative position of particles changes. Now this question has come in JEE Main 2020. It is the same question. See, the location and all will change, but the core idea of the problem remains same. So what is given? A square shape hole has been made in a disk, and they are asking if the center of mass of remaining portion is somewhere here. It will come. It will be always along the line joining. So it is C1. Let's say it is at a distance of x. Then we can calculate the mass of this sigma into area of the disk minus area of the square. We'll get the mass of this. Then this part we can use m, that will be sigma into area of this. And now we can use the mass of the remaining part into this distance x is equal to mass of this square into its distance from here, and this is how we can calculate. Okay, the next part is a disk of mass m with the uniform surface mass density sigma is shown in the figure. The center of mass of the quarter of the disk, so this shaded part, is at the position of so it will be on the bisector of it if it is uniform part, and we can use that result of the disk, which comes as 4r by 3 theta into sine theta by 2, and it will be along the bisector. So directly you can substitute the value, or you can calculate like this. All right. If you want to see, you can check the solution also for this. Next problem. Again, similar type of question is given, that from a spherical cavity, one part has been removed. So you see, sometime it will become disc, sometimes circle and square, circle and triangle, circle and another circle is sphere and another sphere. So this is how these questions will be, but concept and idea will be same for all. If you want, you can take the screenshot for solution and question both. Maybe I'll keep it like this. Okay. Let's move to the next problem. Now this is again, you can see similar type of problem is again in front of us. Half of the square plate. So there is a square but its half is having density of rho 1 and half is having density of rho 2. The length of the plate is L. Locate the center of mass of the plate. Now its center of mass is here, its center of mass is here. We can use the formula m1r1 plus m1r1 vector plus m2r2 vector divided by m1 plus m2. And since here it is uniform, m1 we can write as rho 1 into area of this. Rho 2 into area of this will be the m2. Substitute the value, simplify, and you will get the answer for this part. Its solution is also mentioned, so just try these problems. I'm pretty sure one such problem will be present in your paper if it is coming from this part. Now you see another application. On a cone there is a sphere, and based on that some question has been asked. You can see it, take the screenshot, and you can give it a try. Concept is still same, m1r1 vector divided by total mass, MIRI divided by total mass. Then we have next, from a circular disc. Now from a bigger disc, two small discs are removed. So this time two bodies are given, same formula, same approach. Center of mass of remaining part they are asking. So we are saying, like, when body is complete, its center of mass is here. Now the remaining part, so how we'll calculate? The area into total area of the circle minus smaller areas, that will become the sigma into area of this part as mass, that into r1 vector, then this mass into r2 vector, this mass into r3 vector, and that sum should be 0, and if we simplify we'll get the answer. By symmetry I can say it will be moving somewhere this side, somewhere here on the bisector, so minus I cap and minus j cap. Definitely this cannot be your answer. Okay, so you can check, you can verify that what answer is going to come, but ultimately same formula we are applying. Now this has come in JEE Mains. As I said, different bodies they will give, but idea remains same. We can break this into two parts, either like this, one plate and its center of mass C1, then this part, its center of mass is here. Now we can apply vector m1r1 m1r1 vector plus m2r2 vector divided by m1 plus m2. You can choose center of mass, origin is given here. Anyways, this becomes very easy now. Now this is also a very popular question. A square and a circle is given. So where is the system combined mass, combined center of mass? So very easily I can say its center of mass is here, its center of mass is here. Now m1r1 equal to m2r2 and r1 plus r2 equal to d we can apply. And logically also you can say that since this mass is less, it will be somewhere inside this square only it will come. So you can check directly also. You could comment on this in this form, since they are not asking any numerical value for this. All right. The next part, motion of center of mass. So basically the definition of center of mass, just differentiate that equation. So m1 v1 m2 v2 m3 v3 divided by m1 plus m2 plus m3, that is vcm. So overall momentum of the system, we can write m1 vector m1 v1 m2 v2 m3 v3. So it is basically p1 plus p2 plus p3 vector form, and this we can replace with the center of mass definition, which will become total mass into vcm. Similarly, if you differentiate that, okay, when two particles of masses m1 and m2 are moving at a point with velocity v1 and v2 at an angle of theta with each other, then the velocity of their center of mass is given by. So this is basically vector wise, you can say. We can write p net, pcm we can write. So that will become m1 plus m2 times vector vcm, and then we can use the vector formula for this. All these are extension of this part, so try writing all. It's important. I have explained just now linear momentum of center of mass is the P system basically. Just now I have explained this part. Acceleration of center of mass. One more time you differentiate. So M1A1 will tell the force on one particle. M2A2 will tell force on another particle. M3A3 will tell force on another particle. And that expression becomes M total into ACM, which is net force on the system. And its extension you can see here for this formula, that what we did in terms of P1 and P2, same thing we can do for ACM and VC. Similar to that, same result is coming, even the extensions are same. So any one formula, if you remember, you can always comment for another one. Once you know ACM, so displacement half ACM T square you can apply, provided ACM is constant. Now we know if external forces are not present, then VCM will be constant, and if VCM is constant, then center of mass will be traveling in a straight line path. And if VCM initial is 0 and ACM is 0, then we can say all the time system will be at rest. So there are some characteristics of center of mass. Just take the screenshot and yeah, you can go through it. All right, I'm not explaining this. Let's move forward. I think a lot of pages are there to cover. Mutual forces between two bodies, so internal force is 0. In that case also we can say center of mass will be at rest, and M1R1 equal to M2R2 will be holding true. Just go through these cases. When two particles approach each other due to mutual interaction, like gravity, we can say, in case of two masses, they are moving under the influence of their gravitational forces, we can use all these results. If the system of two particles, when M1 is pushed toward M2 through a distance, that question we have done already, and here result is given. So if you can remember, it's well and good. A buoy of mass M is at one end of the flat boat of mass M length L, which floats stationary on the water. If buoy is moving to the other end, then the boat will move in opposite direction, and displacement of buoy with respect to ground. So all these questions have been covered in the live classes. Easily you can do it. Otherwise you can derive these results. If you can't remember, then you should know the derivation part of it. Same thing is here. Sometime velocity with respect to boat, or velocity with respect to plank, or even the gun and cannon problems are also same thing, on the same concept. Sometimes they will give muzzle velocity. So muzzle velocity is basically velocity of bullet with respect to gun just after firing. That is the muzzle velocity. So you can see two spherical bodies, masses are given m and 5m, radius is r to r, released in free space with their initial separation between their center of mass is equal to this. If they are attracted to each other due to gravitational forces, then the distance traveled by smaller one covered by smaller sphere just before collision will be. So what will happen here, the overall center of mass will be at rest. So either extension of momentum conservation you can use, m1 v1 equal to m2 v2, same way r1 plus r2 is equal to d, and m1 r1 equal to m2 r2 result can be used here. Okay, so this is another application, please take a note of it. Let's move. Now this is JEE Mains 8th April PYQ. Masses are given, and they are asking, they have accelerations of equal magnitude with direction as shown. The acceleration of center of mass of the particle is m1a1 plus m2a2 plus m3a3 plus m4a4 divided by m1 plus m2 plus m3 plus m4. You have to apply. So direct application you can see. It has come recently only in mains. Two blocks are given, a spring is given, placed on a friction. The impulse of velocity 4 meter per second square is given to the heavier block. इसको दिया भैया heavier block को 14 meter per second. the velocity of center of mass is m1 v1 plus m2 v2 divided by m1 plus m2. Same that recoil of gun or recoil velocity of platform when man is standing on it, we can use that. Okay, conservation of momentum we can apply in this. With respect to ground frame, we have to apply. Again, this question is based on conservation of linear momentum. When it reaches the point A, so that time its velocity will be in vertical direction, as well as it will be moving in horizontal direction with the plank. So along X we can conserve linear momentum. And they are asking a speed of bigger block, so it will be in right side direction only. So momentum in X direction will give you the answer. Small mv divided by m plus m. JEE Mains 2019 question, wedge of mass m lies on a perfectly frictionless plane. A particle of mass m approaches the wedge with the speed v. There is no friction between the particle and the plane or between the particle and the wedge. The maximum height climbed by the particle on the wedge is given. The wedge photo is not given, but I'm assuming it is something like this. This is the ground and wedge is like this, and a block is coming from here. So when it is going, its result is independent. Alright, its result is independent. At maximum height, you can say this Vy will be 0, and horizontal direction, these two will have same velocity. And now we can say linear momentum conservation and energy conservation. And when you simplify, you will get the answer. So half m1 m2 by m1 plus m2 v square is equal to m1 gh. Direct result you can get from here. All right. Okay, so I think photo was missing. The same photo is there also. So a block m just reaches the top. So h max is given this time, means we can use the previous result. And they are asking the value of u, they are asking. Okay, let me just solve it. So here I have shown you. So when initial situation, if you see, this velocity is v, so half mu is reduced mass of the system, m1 m2, so it will become 4m divided by m1 plus m2, 5m into v square. This is equal to m g h. M is mass of the block. Yeah, simplify this and you'll be getting the answer. It's matching. Yes, it's matching. H is equal to 2mv square by 5g. Same thing here you can apply. Half mu into v square is equal to mgh. In terms of m and km they are asking, so same thing here. It's easy. Otherwise, conservation of momentum and conservation of energy you have to apply, or half mu v relative square is equal to change in potential energy. Directly you can apply. We have done these type of question in regular class with these short tricks, so you will save all this time of calculation. You see, simplify. If you simplify, you will get the similar result. All right. Next, explosion case, also many questions will come, so that is also based on conservation of momentum. So ratio of masses is given 1, 2, 2, and two smaller pieces fly off perpendicular to each other. So one goes this side, one goes this side. So third will move in opposite direction momentum wise. Linear momentum has to be 0. So if this is momentum 1, this is momentum 2, and they are right angles, so this will become root of p1 square plus p2 square, and that is going to be the value of 3. Yeah, see. After this, just you need to substitute the values and you will get the answer. Same thing here, nucleus disintegrates into two parts which have velocities in the ratio of 3:2. The ratio of their nuclear sizes will be So nuclear sizes is that radius is proportional to a to the power 1 by 3 result, if you know. Okay, they are doing that by using nuclear density to be constant. Well, we have covered these type of question in modern physics, and I think you will know, because that part is common in chemistry also, that radius is proportional to a to the power 1 by 3. This result you can use, and that is based on the fact that nucleus density is same for all elements. Conservation of momentum, and the same result we are using. Anyways, let's move to the next problem. If you want, you can take the screenshot of this particular problem. It's a good problem. Can be useful for a JEE Advanced as well. Same thing is here, projectile motion and explosion. So conservation of linear momentum you can use. A piece of wood, you take the screenshot. A lot of calculation is there. Okay, take the screenshot of this part. Then next, again, this problem is based on conservation of energy, conservation of momentum. Majority of the problems are like this. This is a JEE Mains 2022 problem. All right. Maximum extension, maximum compression. So they should have same speed, and after that conservation of linear momentum and conservation of energy will give the right answer to you. And we can use a very nice result also. Like, we can skip this entire part. I have just told you half mu into V relative. V relative is 2 plus 1, and that should be equal to half k x max whole square. In one line you will get this answer. So these tricks are very handy. Impulsive forces, so force into time, and important point, like gravitational force and spring force are always non-impulsive. Normally we take, but remember, impulse is not necessarily has to be very high force. Normally in collision we consider that, but in general, definition wise, it is just force multiplied by time. And especially in case of massive bodies like planets, this impulse can be calculated over the years. It will be significant, but normally we will ignore. Then particle is projected with the speed of this, and J is equal to mv, you can write. Projectile net impulse, change in momentum, or you can write mg into time of flight. Directly you can write this. Yeah, you can take the screenshot of this problem also. The next, collisions. So very strong forces in interaction for a short period of time. So there are head-on collision and oblique collision. So head-on collisions are when line of impact is along the velocities, and oblique collision when velocities before the collision are not in the direction of impact line. And impact line is the line where impulsive forces are going to act during the collision. Momentum exchange takes place. Momentum exchange will take place along the line of impact only, and perpendicular to that, momentum will be same, no change. So there are three type of collisions. Elastic collision. When we say elastic collision, linear momentum and kinetic energy just before and just after will be conserved. No loss in kinetic energy, no sound, no spark, and bodies will deform for some time and they will regain their shape. That means there will not be any deformation potential energy during the collision. Inelastic collision, there are two cases in inelastic: a general inelastic collision and perfectly inelastic collision. So here what will happen? Bodies will change their shape and they will not recover fully. If they are recovering partially to their shape, that means maximum deformation potential energy, one part of this gets converted into kinetic energy again. So they will not regain their shape. There will be some loss in energy, momentum will be conserved, loss in energy, sound, heat, radiation, everything will be there. All right. And perfectly inelastic means the deformation will be maximum, no recovery in shape, heat losses are maximum, and you can say the heat losses will be uh, due to change in shape, sound will come, spark will come in such collisions. And we can say for elastic, coefficient of restitution is 1, and for general inelastic collision it is between 0 and 1, and perfectly inelastic collision you can say is equal to 0. All right. You can say maximum loss in energy. So this is the impact line if velocities are along this line itself. So we'll say that it is like here you can say this is the impact line, and along this if these velocities are there, then it will be head-on collision. But here I think line of motion of ball B, line of motion of this is oblique collision. This is oblique collision, some mismatch is there. Ball is falling on a stationary wedge. That is also example of oblique collision. This is the impact line along which normal force will be impulsive. Elastic collision in 2 dimensions. So these results, I think this we have done in class. If you want to read it, you can read. Just go through this part, take the screenshot if needed. And these are some of these results. So I'll suggest ki if you can remember this result, it will be very, very important, and literally it will not take any time of yours in solving the problems. So some short results are given here. If you want, take the screenshot of this entire page. Similarly, take the screenshot of this entire page. Okay, now this case is very famous case, easy though. By the way, definition of impulse is relative velocity of separation divided by velocity of approach. So that happens before collision, this happens after collision. So a body is dropped from a height h, then it will rebound to smaller heights, and it will keep doing that. So now based on that they are asking us questions. So basically here you can see when this falls down, its velocity will be under root of 2gh, and when it will rebound, it will be e times under root of 2gh. Based on that we have to find out. Now v1 is known to you, that will become 2gh1. So, and it came with the e times 2gh1, e times under root of 2gh1 should be equal to under root of 2gh. Simplify this, e is e you are going to get in that case. Okay, root h1 by h is given. E is less than 1, so yeah, that's correct only. When a free falling body strikes the ground with velocity, this rebounds with the velocity, then E is equal to v1 by v. Total distance traveled, so it is falling, then h1, h1, h2, h2, h3, h3. So h plus 2h1 plus 2h2 plus 2h3, keep adding it, and h1 result we know, h1 and this h result, h2 and this h1 result, h3 and this h2 result. Same definition of E will come, substitute the value, and we are getting this distance d, total distance traveled. total time taken. So this is time of fall, then up and down, time of flight, up and down, time of flight, up and down, time of flight. So you can write t plus 2t1 plus 2t2 plus 2t3, and a GP will form the same GP as this. Here it was e square, here it is e. Average speed, total distance by total time. We have calculated total time, we know the total distance, take the ratio, we'll get that result. After this, average velocity, total displacement. So this displacement is how much? Basically it is h only, because finally it will be in the ground. Okay, yeah, it's vertical fall. These results you can go through here. Other applications, this is very simple. Now this velocity component will be unchanged, it will be same here also, and this will become E times U component of this. Alright, if it is elastic, then only this angle will be same, otherwise these angles are going to be different. Phi and phi, this will not be same. Bhaiya. Alpha beta is given, you see from that, some printing mistake is there. So phi will not be there. Take a note of this, okay? This will be 90 minus alpha and this will be 90 minus beta. So what we can do in this, change in velocity occurs only along the impact line. Okay? Change in velocity will occur only along the impact line. This is the impact line here. So these velocity components perpendicular to this impact line will be unchanged. Use that fact, simplify, you'll get the result. Now the previous problem at an angle of theta. So time taken for first collision, 2u sine theta by g. Time taken for the next one, let's say this angle is theta 1, and we can use this result. Tan theta 1, theta 2 is equal to tan theta by e. Now just go through this. I'm not deriving these results. If you want, you can take the screenshot of this. Okay, let's move ahead. There is another page also. All right. No, I think and all theory has been completed. Ballistic pendulum. Here also, if it is getting stuck in this, so half mu v relative, so half mm by m plus m into u square, this is equal to mgh result we can directly use. How it is coming? That is loss in kinetic energy. How it is coming? Conservation of linear momentum and energy conservation, we are getting that result. Okay, this collision part, conservation of momentum. Here the actual good idea is instead of going along x and along y, the best idea is resolving impulse or velocity components perpendicular to the impact line and along the impact line, and a definition of E, it will become one-dimensional collision. That is much easier to deal with the two linear equations. All right. Otherwise, apply conservation of momentum along x, along y, definition of E, and by the way, definition of E you'll apply along the impact line, common normal. Okay, now I'll give these questions, you just take note of this. Take the screenshot of this part. Take the shot of this part. This is a standard result I have discussed in the class. So what happens? U1, U2, then equal, then again equally. So here to here, some loss, then here to here, some gain. Then the total loss in this K1 minus K3 you will do, and that will be equal to half mu into V relative square times 1 minus E square. So directly standard result you can use. I have derived in the regular classes. You can take a look at this. On the same concept, this question is based half mu v relative square. I have given the solution. If you want, you can check it, take the screenshot of it. Then the next problem, take the screenshot of this also. Then we have another problem, take the screenshot of this. You see that half mu results are coming. They are very, very important, very, very handy. It will just make all such questions of conservation of momentum. It makes it one-liner. Take the screenshot of this. These are easy problem, but make sure to practice. Detailed solutions are given to you. Take the screenshot of this. Okay, here 38, 39, then 41, 42, 40, 41, 42. I hope you are taking these screenshots for your reference purpose. 43. You can pause and take the screenshot. You can pause and take the screenshot. Okay, I think we are about to end this. Yeah, you can take this screenshot also. A very good problem. Very good problem. Easy also. Yeah, that's it in this video. So guys, if you like these booklets, do give us a lot of likes, help us in promoting the channel and the INSP website. I'll try to make more such books so that we can release all of them before your JEE Mains 1. These are Champs Patch JEE Mains revision booklet. Okay, for advanced we'll prepare separate material. Okay, so